All right, so to wrap up this section, I just want to kind of switch things around. So we've been building up machines or having languages and then converting them into their corresponding regular expressions. What I want to do now is I want to begin with the regular expression and begin trying to actually construct the machine. So this is where we begin to get the kind of more formal connections between all of these things, is that I don't care where you start, they're all going to be able to be reconverted back into one another. If you give me a language, I can build a machine, I can build a regular expression. If you give me a regular expression, I can build a machine for it. Is that I don't care where we go. We got this nice little circle that doesn't matter where you start, they're all going to be interconnected to one another. And there's actually a really cute construction that goes into play behind the scenes. So it's not necessarily the most optimal way to construct a machine, but it will always work. So this gives us this fact that any of these irregular expressions can be converted into these non-deterministic machines. Therefore, they are going to be a regular language. So that was that theorem that we had in the very first thing that said regular languages come about from these regular expressions. They are one and the same. So the expressions, the machines, they're all the same. Okay, enough hypotheticals about that. Let's actually go look at an example, and it's going to kind of showcase all of the things that are going to happen. So here I have my regular expression of, whoa, that's not a pen, that's a highlighter, of 1 star or 0 or 1. So what happens here is that you could think about just building 2 separate machines. So if I wanted a machine that would accept 1 star, that's easy to build. Just loop on 1 as many times as you want. And if I wanted a machine that's going to accept only 0, 1, so that's just one word, 0 followed by a 1, that's easy to do as well. Officially, I'm taking 2 little machines. It's like the machine that accepts 0, followed by the machine that accepts 1, and then I'm doing the concatenation on them, which then puts my accepting state at the very end. So I have 0, 1, and then a final accepting state. To make this nice and cute as one overall machine, then what's going to happen is I'm just going to switch the beginning part. Instead of having 2 separate machines, I'm going to combine them, and I'm going to give them an epsilon transition into it. So the split ski on the epsilon transition is a really cheap way to make the ors, and I'm set there. You could technically go and actually create a very nice deterministic machine for this, or a non-deterministic machine without epsilon transitions, but this is how the construction goes for working with anything. Anytime you have an or, it's going to bring a split ski in the epsilons. Anytime you're going to have kind of the star, you're going to have kind of a looping structure. Anytime you have concatenation, you're just going to glue 2 machines one after the other. All right, let's do that again because it's kind of cute. So here's my slightly better drawn version of that one. All right, so next up is going to be, I want to have a regular expression that's going to accept, or I want a machine that's going to accept 0, 1, or 0, and as many copies of those as you'd ever want. So it's kind of a weird little language. So I'm going to have 0, 1, or, gotta make my ones fancier, they look like the or symbol, or a 0, star. So things that technically live here are things like the empty. We have 0, 1, or we have 0, or we can begin combining these things. So I could take 1 copy of the first one followed by 1 copy of the second, or I could take 2 copies of the first one, and so on and so forth. All right, so just like before, we can actually build this up really sillily in that I'm going to build a machine that's going to work very nicely with my 0 followed by a 1. So that's my top one. And then I'm going to build up a machine that's going to just accept as many 0s as you'd ever want. I can then bring about an or through the epsilon transitions. So I'm kind of working inside out now. So epsilon transitions coming in. And to get the big overall star, we're going to actually kind of do another silly thing that we're just going to allow us to go back to the beginning on an epsilon as many times as we'd want. So if I am here, I can come back on an epsilon. And if I'm here, I can come back here on an epsilon as well. So officially, the little stars can always just be done by having kind of a teleporter back to the beginning. Officially, the little like 0 star, the looping on that, can be done with the little teleporter as well. I like to just draw it out as the looping on 0, but you could have also introduced another teleporter there to kind of see all of these worlds collide. So you can build this up in this really kind of strange world, but it technically works. Is that any regular expression you'd ever want, you can go through and begin gluing these things together. So if you remember all of the regular expressions that we had, so kind of the laundry list of how these were built up recursively, you can begin to see the overall process take hold. Basically, how do you do, the empty set? How do you do the set containing the empty set? How do you do a single letter, a union? How do you do concatenation? How do you do this star? If you know how to do each of these little parts, just let the recursion go crazy, and you can technically get any regular expression converted into one of these machines. So that's officially the big theorem that we started with, and kind of a mental thought for how those little machines all come into play. You can build a machine that accepts nothing. You can build a machine that only accepts the empty string. Notice the subtle differences between those. Not accepting anything versus just accepting the empty string changes just a lollipop into a lollipop with a circle in it. A machine that accepts a singleton character is easy. A machine that accepts concatenation, what you do is you take machine A and you glue machine B onto it. Machines that accept ORs, just epsilon splitsky it, and then machines that accept looping, so the stars. So here's how I normally like to draw this, the loopings, just I can do it on a 0. You could also do it on the epsilon transition as well. That's kind of what I was alluding to about 30 seconds ago, is that that little thing also accounts for any number of zeros, including no zeros at all. So I'm not going to go super formal into that just because it's kind of a technical nightmare. But if you can get all the little base cases, then letting the recursion go crazy, and you can build whatever regular expression you'd ever want to out of just these minimal little pieces. In the next section, we're going to begin hitting it really hard on introducing all of the extra special things to make the typing of regular expressions a little bit better. So the actual application side of them, and how we can begin to see some of those and then kind of fully live in this world a bit longer. So it's cool, it's fun. There's a lot of really terrible regular expressions in the world, so hopefully you are not one of the people that will create terrible regular expressions, but you will be one of the people that make beautiful, awesome, simplistic regular expressions that never break. So that's the hope. So we'll come back next week and see a few more things like that.